In today's class, we'll study about refraction of light, laws of refraction, relative refractive index, absolute refractive index, and relative refractive index in terms of absolute refractive index. What is refraction of light? We all know that light travels in a straight line in a given homogeneous medium. Now, what happens when a light travels from one medium to another medium, like air medium to water medium? Here, the light changes its path and travels along some other straight line. So, we can say that the phenomenon of change in the direction of the path of the light when it goes from one medium to another medium is called refraction of light. Now we'll see what happens when a ray of light travels from rarer medium to denser medium. So we consider a plane xy which divides the rarer medium and the denser medium. Now let us consider AO be the incident ray. At the point of incident, let us draw NO and dash as a normal. Then what happens? A ray of light travels from rarer to the denser medium. The refracted ray bends towards the normal, that is OB as a refracted ray. Similarly, when a light travels from a denser medium to the rarer medium, it bends away from the normal. So, we also know that angle made by incident ray with a normal to the surface is called the angle of incident, and angle made by refracted ray with a normal is called angle of refraction. Now we'll state the laws of refraction. The first law of refraction is that the incident ray, the refracted ray, and the normal to the refracting surface at the point of incidence all lie in the same plane. The second law states that the ratio of sine of angle of incident to the sine of angle of refraction is constant for a given pair of medii and for a given color of light. That is, sine I by sine R is equal to constant. This law is also known as a Snell's law. Snell's law cannot be applied for the normal incidence because at that point the angle of incidence is 0 and also the angle of refraction is 0. Further, we'll study about relative refractive index. Let us define the relative refractive index. The ratio of sine of angle of incident to the sine of angle of refraction is called relative refractive index of second medium with respect to first medium, and it is denoted by N is equal to sine I by sine R. And also considering the velocities of two mediums, we can write the refractive index is equal to V1 by V2. Now we'll talk about the absolute refractive index. Refractive index of a medium with respect to air or a vacuum is called absolute refractive index, and we can say that N is equal to C by V, where C is equal to velocity of light in air or vacuum and V is equal to velocity of light in a medium. Now we'll see relative refractive index in terms of absolute refractive index. For refraction from vacuum to medium 1, the refractive index is N1. We can write it as N1 is equal to C by V1. We consider this as equation 1, where C is the speed of light in vacuum. Similarly, for refraction from vacuum to medium 2, which has a refractive index N2, N2 is equal to C by V2. We consider this equation as 2. From equation 1 and 2, we divide N2 by N1, we get it V1 by V2. We consider this equation as 3. As we know that V1 by V2 is equal to refractive index of second medium with respect to first medium, we consider this as equation 4. From equation 3 and 4, it says that refractive index of second medium with respect to first medium is equal to N2 by N1, which is refractive index of medium 2 divided by refractive index of medium 1. From Snell's law, we can say that refractive index of medium 2 with respect to medium 1 is equal to sin I by sin R. So we consider this as equation 6. From equation 5 and 6, we write it as sin I by sin R is equal to N2 by N1. That is, N1 sin I is equal to N2 sin R. These equation helps you in solving the numerical problems. In the next class, we'll study about total internal reflection.